Hello, we are going to do section 1 notes, the second video, and it starts on page 3 in the notes packet. Last time we talked about sketching a graph, or a graph from an equation, and then how to identify x and y intercepts. Today we're going to talk about sketching parent functions and all their different characteristics, except for the greatest integer function, which I'm going to do as a separate video. This video is kind of longer than normal, so that'll help to have it broken down a little bit. All right, so finding and plotting points, we've already done. We've done x and y intercepts, so we're going to go to page 3, and you can see here that what I have in place is just some of the vocabulary that we'll be using. And so let me make that large enough that you can see it easily, and we can talk about it. So domain and range should be familiar. Domain just simply is talking about all the possible x values on the graph, and range is all the possible y values on the graph. And then when we talk about increasing, decreasing, and constant intervals, all we're doing is we're following the graph from the left to the right. So think about it. If you're following the graph from the left to the right, then as x increases is what you're saying. So we're going from left to right, so x is getting bigger, and as that happens, we're finding out what is going on with y. So as we go from left to right, if the line or piece of the graph is going up, then we would say it's an increasing interval. But if we go from left to right and that part of the graph is going down, then we would say it's a decreasing interval. And then, of course, if we're going from left to right and it's staying at the same position, then we're going to say that it's a constant interval. And we name that in terms of x. And so that might be worth underlining or circling, but we do that in interval notation form using x. Okay, so we name it based on what's going on with x. All right, and then the highest relative point and the lowest relative points are the maximums and mins. That's just the highest or lowest point or points on the graph. Okay, so there could be more than one maximum, and so it's not an absolute maximum. It's like all the possible maximums, all the possible minimums. Okay, and then left-in behavior and right-in behavior may be different. I don't know if they covered that in Algebra 2. But all it's talking about is as we go to the left side of the graph, as we approach from the right going towards the left, what is happening to the y values? And so that would be left-in behavior. And then right-in behavior is as we go far off to the right, so we're approaching from the left going towards the right, what's happening to the end down there? And we write that in limit notation. So the limit of f of x the limit of x as x approaches a, so as x approaches the end, okay, of f of x is whatever y is. So in other words, what's happening with y as x gets smaller and smaller, and sometimes smaller and smaller means negative infinity, and sometimes it means it's getting as close to 0 or some value as it can get, because there's an asymptote there, and we'll see that. And then the same thing with the right end. The limit of f of x is approaching what value? And so as x gets larger and larger, so in the way we read this is the limit as x approaches infinity or x approaches some value of f of x is equal to what? Okay, what y value? So what's happening with y as we go far off to the right? So we're going to do some of these so you can see it in detail with the different types of parent functions. Now, you do need to memorize these parent functions. You need to be aware of what they are and their characteristics. Now, you just really have to memorize what the parent function is, and then from there you should be able to look at it and tell us the characteristics. So let's start with domain and range. Okay? So we're going to start with a kind of a weird function, just the constant function. And one thing I'm going to point out, if this had a closed, like a dot right there, then we would know it stops there. But since it's just a line and there's not a closed dot or an open dot or anything like that, then we're assuming that this will go on and on. Okay? So you can assume those go on and on. And so for the domain, what is the smallest x value that you could get? Well, if it goes forever to the left, then the smallest you can get is negative infinity, right? And then it goes forever to the right, so remember this is in terms of x. Now, in the book, it writes it like this. X is an element of, or is a value in, okay, from negative infinity to infinity. So it's just saying, hey, the x that we get is somewhere between negative infinity and infinity. Now, you don't have to write this x. It says x is an element of, is what that little e means. But you don't have to write it that way. You can just write negative infinity to infinity. Now, for range, it is a little different because the only value for y, there's only one value for y, right? And so this time you do kind of have to use the symbolism. So y is an element of whatever c is. Now, what do I mean by c? Well, I don't know what that value is. I don't know if it's 1.4, 1.25. I don't know what it is. So I'm going to call it c. Okay, so it's just whatever that actual value is. Y has to be that value throughout the whole graph. That's what that's saying. And then x-intercepts. Well, does it ever hit the x-axis? No, and so we would say none here. And then y-intercepts, well, it does hit the y-axis, but where does it hit the y-axis? Well, at c, and we would say it hits it at x when x is 0, y is c. We write that as an ordered pair. Then, if we talk about increasing, decreasing, and constant, remember you put your pencil on the far left of the graph and you go towards the right. And as you're going towards the right, what is the y value doing? Well, in this case, it's not changing. It's staying the same. So we would say that it's constant over this whole domain. So it's going to be constant from negative infinity to positive infinity. And it's never increasing and it's never decreasing. And then the local maxes and mins are also tricky because in this case, the max and the min are the same value, right? And so we would say that the max happens at y equals c, and we'd say that the min happens at y equals c. And so that's how we would define that. Now, you can write max and mins as ordered pairs also, but in this case, that would be an infinite number of ordered pairs, so it's easier just to say y equals c, because you can write it in terms of y. And it makes sense if you're talking about how high or how low that we would name that in terms of y. And then the last part is the end behavior. And so you got to get used to writing this limit notation properly. So I write the LIM, and then underneath it I'm going to write x arrow, okay, so as x approaches. And then what is x approaching as we go lower, as we go left, where is x going? Well, it's just getting smaller and smaller, right? So x is going towards negative infinity on that left end. And so we're saying, what is the limit as x goes to negative infinity for this function? And so what is happening? What's happening to the y value as we go from towards the end, left end? So the y value is not changing, is it? So it's actually staying at c. And then the right end behavior, we would say the limit. Make sure you have your x and arrow right underneath the limit, and the f of x is right next to limit. So we're going to say the limit as x approaches. Now we're going to the right end. So if we go towards the right, well, x just continues to get larger and larger, right? And so it's going towards infinity. And so the limit as x approaches infinity for this function is. And what we're really saying is, what is the y value as x gets larger and larger? Well, the y value is still c, isn't it? Okay, so that's what's happening on the ends of the graph. That's why it's called end behavior. All right, so that's the constant function. So let me move this up, and we'll do the linear function. Linear function probably feels more comfortable for sure. So the linear function is just y equals x, or in this case it's f of x equals x. And as I go through this, it's the same kind of thing. I say, okay, what is the domain? So remember, there's not any dots on the ends here, so we are assuming it continues on, okay? And so the farthest it goes to the left, well, it just continues going to the left, and it just continues going to the right. So we're going to also name this from negative infinity to infinity. And then one thing I want to point out up here, when I named that as C, notice I used brackets here because C was included. It was actually on the graph. Where here, you can't include infinity, so it's always in parentheses. So I just want to point that out real quick. Okay. And then for range, it's going forever down and forever up, right? So we're going to say negative infinity to infinity. So that's going to be the same. The intercepts are the same. The x-intercept, it hits at 0, 0. Well, that's also a y-intercept, because remember, x-intercept is you let y equal 0 and see what x is, and y-intercept, you let x equal 0 and see what y is. And so those are the same point. And then now we're into the increasing, decreasing constant. So put your pencil on the graph to the left, and then go towards the right. And as you go towards the right on the graph, what is happening? As we go towards the right on the graph, from left to right, this interval's going up, isn't it? And so we would say it's increasing, and it never actually goes back down or starts leveling out. So since it's forever increasing, it's increasing over the entire domain. So we would say from negative infinity to positive infinity, it never decreases and it's never constant. Okay? And then, I'm going to move my picture because it's in the way. So then now as we look at this, we go, okay, what about local maxes and mins? Well, since it's never has a highest point or a lowest point, we can say this is also none. And now we're just to left-hand and right-hand behavior. So we'll say the limit as x approaches, and since x is going to go forever to the left, then we're approaching negative infinity as we go from the right to the left of this function. And then what happens to this as we're going towards the left end? So if we're following this towards the left end, what's y value doing? Well, it's going down forever, isn't it? And so we're going to say y is going down forever. I was trying to erase that. I had accidentally made a mark. Okay, so we're going to say y goes down forever, so that's negative infinity. And then for right-hand behavior, we would say the limit as x approaches. Well, what is x approaching? It's approaching infinity. So as x approaches infinity, what is y approaching? Well, it's also approaching infinity, isn't it? Okay, and so we could we would read this as the limit as x approaches infinity of this function equals infinity. All right? That's not too bad, right? All right. If you have questions as you're watching the video, write them down so you'll know what they were and you can ask about it. Okay? All right, let's go on to the next page. I think the next thing is, my picture is really in the way. I don't even know if I should have it on here. It's crazy. Oops, cancel. Let's see, what page are we on? We're on 3, so we're going to go to page 4. And let me make this bigger and maybe put this in the left corner. Okay, so this next function, it's really small. This next function is the squaring function, but we also know it as a quadratic function, right? And it's called even. That term even simply means that if we were to fold this along the x-axis, it would match up perfectly. So it has symmetry across, the y-axis. It has symmetry across the y-axis. So if we're folding it on the y-axis, it would match up perfectly. So we would say it has symmetry along the y-axis. And so y-axis symmetry, which it's not part of the lesson this time, but it will be eventually, so you might as well start learning that. So y-axis symmetry is considered even. So the line would not be even, right? Because it doesn't fold so that it matches up. So we couldn't call it even. So now when we look at domain, remember once again, there's arrows on the end here. Okay. And as we go through this, let me extend my window here. Okay. So the domain is going from left to right. So if you think, how far to the left is this equation going to go? Well, it's just going to keep going left, isn't it? And this one's just going to keep going right. And so once again, we're going to say negative infinity to infinity. Okay? Then for the range, it's different because it does have a low point. So it's included. And so the lowest point on the y-axis is 0. And we would put a bracket to show that 0 is included on the graph. If there were an opening here, we would put a parenthesis here. And then how high does it go? Well, then it goes up forever, doesn't it? So then we do a infinity parenthesis. And then now, if we look at x-intercepts, well, where does it hit the x-axis? Well, at this point, right? And so that's the point 0, 0. When it happens to also be hitting the y-axis at that point. And so that's also 0, 0. And now we're going to continue this on and say, okay, what's happening as we go from left to right on this graph? What's happening? Is it increasing? Are the y values getting larger, smaller, or staying the same? So as we go from left to right in this section, it seems like it's decreasing, doesn't it? And then as we go from left to right in this section, it seems like the graph is increasing. And so we would say that it's decreasing from negative. Now remember, we name this with the x value. So this x value is going forever to the left. So it'd be negative infinity up to, and then it stops decreasing at 0. And we can just write decreasing and increasing in constants with parentheses. We don't have to talk about included. And then from there, it goes from 0 to infinity. So then it's increasing when x is 0 all the way up till forever, right? For x. And then there's not a time when it's just constant, because really this point isn't included as a constant point, okay? Remember, it's an interval, not a point. Okay. And then for local maxes, there's not a local maximum, so we would say none. But there is a local minimum this time, right? The lowest point, which is 0, 0. And then for in behavior, we would say the limit as x approaches. So x is going to go forever to the left, so as x approaches negative infinity of this function. Notice I'm writing the f of x in line with the limit. It's like they're on the same line. Okay, and the x approaches negative infinity is right underneath that. Okay, so what's happening as we go to the left? What's happening to the y value? Well, it's going up, isn't it? So we would say that's infinity. And then the limit as x approaches positive infinity, because we're going forever to the right, of this function. Well, now what's happening as we go from the left to the right, at that end, it's just y is getting larger and larger, so we'd say that's positive infinity. Well, it turns out that they're going in the same direction on both ends, aren't they? So we could have written that as one phrase, the limit as x approaches negative and positive infinity of this function equals infinity. But because it asks for left end and right end behavior, I wrote them separately. Okay? All right, let's talk about the cubic function. So for the cubic function, it's also called an odd function. And odd means that if we were to rotate this 180 degrees or rotate it across the origin, okay? So if we were to rotate this, it would be the same picture. And that's what makes it an odd function. And so we would say, in this case, we would say it has origin symmetry, which once again is not in this lesson, but it will be eventually a lesson, so you might as well start picking it up. So it has origin symmetry. Now a line that goes through 0, 0 also has origin symmetry, right? Because you could rotate it 180 degrees and it'd be the same picture. Okay? All right, so it's a cubic function, y equals x cubed. The domain, once again, is going from negative infinity to positive infinity. The range is also from the lowest to the highest point, is going from negative infinity to positive infinity. Okay. The x-intercept and the y-intercept are both the same. They're at 0, 0. Okay, and then we have to talk about increasing, decreasing, and constant. So we start at the left and we go towards the right, and what is the y value doing? Well, it's continuing to go up. And even in this section right here, it's increasing slightly. Even though it may not look like it, it is increasing slightly. If you put it in a calculator, y equals x cubed, and you trace it, you see it's just continually going up, just not as much in this region. It's not increasing as fast in this region, right? And so we would say it's increasing over its whole domain, and its domain is negative infinity to positive infinity, so it's increasing that whole time. So it's never decreasing, it's never constant, okay? And if we look at the local maxes and mins, there's not one, right? Because there's never a low or a high point, and so we would say none here. I keep hitting my little clicker on my pen. You know, just trying to entertain you. So we would say there's not a local, local min or max. So then now for the limit, we would say the limit as x approaches negative infinity, because we're going to continue going to the left for x, of this function. So what is y doing as we go towards the left end? Well, it's going down, so we'd say negative infinity. And then for right end behavior, we'd say the limit as x approaches positive infinity of this function. And as x goes to the right, what is y doing? Well, it's continuing to go up. Okay? Good. So that's the cubic function. And now let's talk about the square root function. So the square root function is different because see how it starts at 0, 0? And so we have to show that in the domain. So we show it with a bracket because 0 is included. And so from the left to the right, so we're going 0, and then we go forever to the right, so we're going from 0 to infinity. And then it turns out the range is the same because the lowest point is also 0, and it's included, and then it goes forever up. So it has the same domain and range. Okay? Then the x-intercept, it hits the x-intercept and the y-intercept once again are the same. They're both at 0, 0, where they hit the x and y axis. And now we have to decide about increasing, decreasing, and constant. So if we go to the far left of the graph and then go towards the right, what is the y value doing? Well, it's increasing over the whole domain. And the whole domain is going from 0 to infinity. So that, remember, we name it based on the x value. So it starts at 0 and then continues to go up forever. And so that means it's not decreasing, so we can say none there. It means it's not constant at any point, okay? The local maxims, there's not a local max, right? There's not a high point, but there is a low point, right? There's a local minimum, okay? And so we would say this minimum value is 0, 0. We'd write it as an ordered pair, or you could say y equals 0. You can write, remember, you can write mins and maxes in terms of y, and that would be okay too. And then the limit as x approaches. Now this is different because what is the lowest value x can be? Well, the lowest value it can be is 0, and it's approaching that 0 from the right. So we would say a little plus symbol as almost like a exponent, okay? And so the limit as x approaches 0 from the right, okay, of this function. So we're saying what's happening as we go towards 0, what's happening to the y value? What is it? What value is it approaching? Well, it's also approaching 0, isn't it? Okay? Does that make sense? And then here we would say the limit as x approaches, now this time x is just continuing to get large on the right side, so we're going to say as x approaches infinity of this function. And then as x gets larger, what's the y value doing? Well, it's continuing to go up. Okay, so that's infinity. All right, we're cranking them out, guys. Now we're to logarithmic functions. And that is not a function I think that you've studied yet. It was in Algebra 2. It's supposed to be in Algebra 2. Y'all didn't cover it last year, but it's just one of our parent functions. One thing you did cover was exponential functions, and this is the inverse of the exponential function. And so what you need to know is that this x-axis right here, it is an asymptote. I'm sorry, this y, why do I keep doing that? This y-axis is an asymptote. And what that means is that this graph will go along here and it'll get really close, but it won't actually hit the y-axis. And so the starting point is near 0, but it doesn't actually hit 0. And so but then what do you write it as? You write it as, as close to 0.00001. I mean, you could do that forever, right? And so what we do is we show a parenthesis with a 0. So that's saying, hey, it's close to 0, but it's not exactly 0. 0 is not included. And then from left to right, so then it goes to infinity from there. Okay? And then, oops, I put that in the wrong place. Let me move that. But y'all were wondering what I was doing there. All right, so it goes from 0 towards infinity. And then the y value, actually the lowest value goes down forever and then continues to go up forever. So it's still negative infinity to positive infinity, lowest to the highest, right? And then it doesn't actually hit the y-axis, but it does cross the x-axis at this point right here, and that point is 1, 0. So 1, 0 would be my x-intercept, and there's not a y-intercept because it doesn't cross the y-axis. And then as we put our pencil on the graph and we go towards the right and follow the graph, what is the y value doing? Well, it's always increasing. And so we're going to say it increases over its domain. So that's from 0 to infinity. We said the domain was 0 to infinity. It's not decreasing. It's never constant. There's not a local max or min, so we'd say none for those. So really the only thing we have left to do is write the end behavior. So this is the limit. Now, this is the limit as x approaches. What is x approaching? Well, it's approaching 0 again, right? So as x approaches 0 from the right of this function, and as x approaches 0, what is the y value doing and continuing to do? Continuing to go down, isn't it? So that's negative infinity. And then this one is the limit as x approaches. So what is x approaching on the right end? On the right end, it's approaching infinity. And so then what is y approaching as x gets larger? Y is also approaching infinity. Okay? All right, we're getting there, guys. We're almost there. Let's go to the next page. You're like, you lied to us. We are almost there. We're getting there. I know this is long. Okay. Let me make this a little bit bigger. Oh, didn't mean to draw on it. Okay, so now we're at exponential functions, which remember I said it was the inverse of the logarithmic function. And you've heard a lot about exponential growth probably over the last little bit of time. And so with all the corona stuff, it was at one point growing exponentially. Might still be. I haven't looked today, but and at the trend, the 7-day trend lately. But anyway, so this is also, this x-axis is also going to be an asymptote, just like on the logarithmic, the y-axis was an asymptote. So what's happening here is that this is getting closer and closer. So this is going up forever on the right, but as you go to the left, it's just getting closer and closer to 0. But it doesn't actually hit 0. And so, but it does go forever to the left. And domain is talking about left to right. So it's going forever to the left and forever to the right. And so this time, this is negative infinity to positive infinity. And then range is the lowest y value. Well, the lowest y value is 0, but it doesn't actually hit 0. So the way we show that is with a 0 and a parenthesis, and then it does go forever up from there. There are not any x-intercepts because it doesn't hit the x-axis, but there is a y-intercept. It hits the y-axis at 0, 1. And I don't know if you remember from the previous page, but the logarithmic one hit the x-intercept was 1, 0. So they're flipped, aren't they? That's part of being an inverse. And then now as we start at the left end of the graph and we go to the right, what is the y value doing? It's always going up over the whole domain. So we're going to say it's increasing from negative infinity to positive infinity. It's not decreasing. It's never constant. And now we're going to do the limit notation. So the limit as x approaches, and what is x approaching? Well, x is going forever to the left. So x approaches negative infinity of this function is, and then as x goes further and further to the left, what's it getting closer and closer to? What's the y value getting closer and closer to? Well, the y value is getting closer and closer to 0, isn't it? So its limit is 0. And then here we would say the limit as x approaches infinity, because x is getting larger and larger, of this function. And then what is the y value doing as we go to the right end? Well, it's going up forever, so we say infinity. Oh, and I forgot to write the local maxes and mins, but there aren't any, so we would say none here, because there wasn't a lowest point or a highest point, because remember, this is continuing to get smaller and smaller. All right. So the next one is called the reciprocal function. It's a little bit different. So in this one, the domain, so this time the asymptote is the x-axis and the y-axis. And the domain is going, it's kind of weird, so I'm going to write it up here so I have more room. It's going from negative infinity, but then it kind of gets stopped at 0, doesn't it? And it jumps. Now 0 is not included in that. So it sort of jumps, so we write an or symbol, that U is an or symbol, and then it picks back up on the other side of 0, so we say or 0 to infinity, because then it goes forever to the right after that. And the same thing with the range, it goes forever up, then it jumps, and then it keeps going up. So it's going to be the same thing, it goes from negative infinity to 0, okay, and 0 is not included, or 0 to infinity. So it's coming up, and then it sort of jumps, and then it comes up again. And there aren't any x-intercepts, and there aren't any y-intercepts. And then we talk about going from left to right. As we go from left to right on this graph, what's y doing? In this part it's going down, right? So here it's decreasing. Okay, now let's go from left to right on this part. If we go from left to right, what is the y value doing? Oh, it's still decreasing. And so it's decreasing over its whole interval, over its whole domain. And so we're going to say negative infinity to 0, or 0 to infinity. In other words, hey, it's decreasing the whole time. It's never increasing. It's never constant. Okay, there aren't any maximums or minimums. And so all we have left to do is write this in behavior. So we're going to say the limit as x approaches, and as x is going forever to the left, right? So we say negative infinity of this function. Okay, so as x goes forever to the left, what's the y value approaching? Well, it's approaching 0. And then the limit as x approaches, so x is going forever to the right, then what is the y value approaching? So as we go to the right, what's that end value getting closer and closer to? It's getting closer and closer to 0. Okay? And then the last function that we're going to cover today, I know you're delighted, is the absolute value function. And so the absolute value function, it almost looks like a parabola, except it's that straight line, right? And so the domain is still going to go forever to the left and forever to the right. So we're going to say negative infinity to infinity. Range, though, starts at 0, and 0 is included. So we write a bracket, and we say from 0 and then forever up. Okay. There's an x-intercept, right? It hits the x-axis at 0, 0. And it also hits the y-axis at 0, 0. And then we got to talk about, as we go from left to right on the graph, what's happening. So as we go from left to right, here, it's decreasing. But as we go from left to right here, it's increasing. So we have to label that according to x. So it starts at a negative infinity on the x-axis, right, up to 0. So the decreasing interval is negative infinity up to 0. Remember, we don't have to worry about brackets on increasing and decreasing. And then increasing, it starts at 0, and it goes towards infinity on the increasing. And then it's never constant. Okay? There's not a local max or a high point. Okay? So we'd say none there because these keep going up. But there is a low point, and that's at 0, 0. Or you could say y equals 0. And then now it's the limit. So the limit as x approaches. Now x can go forever left and forever right. So we're going to say as it's going to the left, it's approaching negative infinity. What is the y value doing? So as we go to the left, what's the y value doing? It's going up. So we'd say infinity. And then the limit as x gets really big, so as it's approaching positive infinity of this function. So if we put our pencil on the graph and we go towards the right or end, then what is the y value doing? It's getting large, and so we'd say positive infinity. So it's going up on both ends, right? So that should look the same, except for the negative and positive infinity. All right, so that's the parent functions that we have so far, and we'll do a separate video for greatest integer function. Have a great day.